Two modules. First of all, I'm Ted from Advanced Tech, and then you have Steve Mark, who's doing the filming behind you. We're going to do a quick training on clean room protocol, and then we're going to talk specifically about a sensible cooling chilled water pump that's in the clean room. We have a slideshow that's going to go through the protocol training. Then after we conduct this training in the conference room here, we're going to go to the clean room, and Steve will demonstrate with some of the supplies we have here how to properly enter the clean room and get gowned up, and then how you would de-gown, okay? So that being said, you have this module in front of you. These are the items that we're going to discuss, which we're going to go through the training slideshow, which is our protocol training that we use for construction. The item number 2 is going to be discussed in the clean room. Same with item 3 and item 4. So this is the clean room protocol training. And an introductory, what is a clean room? This is what we're going to get out of this module, is what is a clean room, how's it measured, and how can I affect the contamination of a clean room, right? How does construction of a clean room affect me? What are the different requirements at each level of construction? A lot of these are related to training when we have our construction team, right? During the process of construction. Overview training session encompasses the clean room construction of the new clean room facility located here at Temple University. So defining a clean room: designed, built, and operated to provide cleanliness, control, and/or isolation. Built with smooth, hard, cleanable surfaces, which you'll see when you look through the windows of the clean room. Right now, I don't think we can enter the clean room, right, Steve?
Ted, what is that on the bottom?
I don't know what that is. That's not me.
Airplane.
I don't know what that is. I think it's something to do with
That's the
the
TV
monitor.
itself, I think.
So you'll see that when you look through the window of the clean room of the surfaces in the space, you'll see an epoxy floor, you'll see polypropylene furniture, you'll see smooth surfaces on walls, ceilings, and what have you. So the next item, air filtration systems, is critical. So we have HEPA filters. And then we have strict procedures for control and operation, personnel, and process and materials entering the clean room. So why have a clean room? To protect the product or process from contamination, to restrict access to the product or process, to contain hazards located within the clean room. So what is contamination? So run through here, you can see that, solid, liquid, or gas, organic or non-organic, airborne, surface, chemical makeup, size and shape, static charge. Micron, we look at clean room particulates in the size of a micron. It's typically on a half micron size. So what is a micron? 1 micron is 1/1,000,000th of a meter. So micron sized particles are smaller than what you can see. Width of your human hair gives you an example of your hair is 75 microns. Average human can see down to 50 microns, and it talks about other items. So clean room filters are designed to bring it down below 0.5 microns. And this here, you'll be presented with this slideshow after this presentation, but you can actually go through and see different materials and particles. How is clean room contamination measured? Like I mentioned, it's measured in microns. 1 micron is 1/1,000,000th of a meter. There are 25,400 microns in an inch. Human hair is 75 microns, and we can see down to 50 microns. And bacteria is approximately 2 to 10 microns in size. And how do we measure it? Cleaners are measured amount of 1/2 of a micron in 1 cubic feet of sampled air. And today we're actually going through and doing our clean room certification where we actually measure that. And what you'll also see on this clean room is there's a control panel on the outside that's continuously monitoring the space at a specific point for each of the 2 rooms. Now, in our case, on this particular clean room, the first room you walk in from the entry is a class 1000 clean room, so no particles over 1000, or no particles more than 1000. Then you have the second space as you go through the second airlock, and then you'll be entering a class 100 space. And this talks about the classifications, so I kind of touched on. This talks about most people that have been in the industry use Federal Standard 209E, and then they use an ISO standard. So if you're familiar with both, you can see how it correlates. So, like I mentioned, the first room is the class 1000, which is equivalent to an ISO 6. And you can see here that we can have up to 1,000 particles of 0.5 micron size, right? The second room is a class 100, which is equivalent to an ISO 5. As you can see, as the numbers go down, it gets cleaner, right? So these are the items that need to be concerned with. So what generates contaminants into the clean room? Obviously, personal activity is probably the biggest culprit, other than housekeeping. So you have moving, talking, breathing, scratching, sneezing will generate particulate into the clean room. Anything off your skin, I guess if you're a smoker, your hair. So all these items relate to contamination. Same with materials. We don't want any cardboard or wood products in the clean room at any point in time. We don't like to have drywall, because if it gets nicked, that's going to generate particles. We don't allow pencils, duct tape, and I mentioned cardboard and paper, and paint coatings also. So that's why you'll see the surfaces in the clean room are all non-shedding surfaces. Also, equipment that's going to generate particulate matter, obviously electric motors, scaffold, ladders, anything that's got moving parts, right? So this gives you an idea of how many particles are generated in parts per million based on certain activity levels. So if you're just sitting still, you're generating about 1,000 parts per million. Walking at a slow pace, you're over 5 million, and so on. So clean room testing, so we're going to measure airborne particle counts. We can measure surface particle counts on horizontal surfaces. We can measure the airflow parallelisms coming off the HEPA filters. And we can also measure the utility cleanliness. So we're going to certify the room today, which we're going to be taking samples, 1 per each square foot. And then there'll be a certification report from an independent testing agency that will show compliance. So our goals when we're building this space is we want to minimize and remove any contaminants from the environment. So we don't want to allow, we build it clean is the goal. So and we continuously clean as we're building. Then we do the final cleaning at the end right before certification. So currently there's a team downstairs, upstairs that's doing the final cleaning. And then we're always concerned about electric static discharge. So we have humidification in there, maintaining the proper humidity levels to minimize that. Obviously things are grounded. The next few slides, I don't really have to get into detail, but this is just so you understand when we're building the clean room, the levels of protocol. So like level 1 is almost somewhat standard construction. We don't need to be gowned up during this process, just so you're aware of it. Typical PPE that's required. And that's the type of activities you would see on level 1, which is more or less the roughing in of the space. And we're trying to make sure that the space is, dry during construction. And as we get to each, right before we get to each level, we do training with each of the subs to make them aware of what's the next expectations for the next level protocol. And we want to keep this, basically keep the site clean and the, envelope clean until we get a box that's sealed and pressurized. So all the housekeeping is super critical at that point. And we talk about material prep before it enters the space. We're trying to eliminate anything that generates particles like we discussed previously. And these are the typical construction activities that would happen during level 2 protocol. And then the items that we'd like to complete before we would proceed to the next protocol. So we basically want to have room pressurization in controlled environment. And this is like a standard for most projects. This project was a little different, but this is kind of geared up to most clean room design build projects. And then prior to going to a level 3, at the end of level 2, we do a training. In level 3, we have continuous pressurization air, continuous cleaning. In some cases, we implement the use of an automatic shoe cleaner at the entrance of the space. In some cases, we put a temporary gown room. We didn't have the space here to do that. And then we have designated areas for prep areas when we have the space. And we don't allow, like I said, wood or paper products in the space. And we typically use vacuums with HEPA filter media in it. Construction activities at that point is we're putting in the ceiling components, process utilities, and so on. In this case, we actually had an epoxy floor. That was done earlier. And then before we get to the next level protocol, all the finishes are done, and basically all the utilities are run into the space. We got a sealed environment, and we do training for level 4 protocol. Then we're in level 4 protocol. Then we're implementing, shoe cleaners, shoe covers, hair nets, etc. And then the construction activities is where we actually install the HEPA filters. In this case, we have fan filter units in the ceiling that does our recirculation air, and we have room-side replaceable HEPA filters. So we've actually recently installed these. Final super clean in this case is going on right now. And then we do training for level 5. I don't think we're going to level 5, right, Steve, on this job? It's basically a continuation. So once the room's all built, you want to maintain at the highest level possible, right, to keep the space clean. And obviously you have housekeeping that's necessary to do that. Level 5, we do tool install, which we recently completed on level 4. And then we generate a clean zone plan, so we have a controlled entrance. In this case, it was pretty simple. We actually used the entry that's going to be used for operation. That's what we use as our entry point. And then at some point the university is going to have to purchase gowning materials. It talks about the clean room garments, which we'll get into, which you typically would have shoe covers, some cases hair net, beard covers, lab coat, depending on the level the university is expecting to maintain the space. We'll get into the gowning sequence. Typically want to leave all street clothes, outside the clean room environment, and in a locked space. And we want to make sure the your shoes are clean. We're using the shoe cleaner. In this case, I don't think we have one here. Then we would enter the space, which you'll actually see there's tacky mats in the gown room, and that's where we'll put on our shoe booties, and then we enter the gowning room. And then again, it's up to the university, but we would recommend putting on hair nets, and if you have a beard cover, then you'd put on your gloves. Then we would have a Tyvek suit that you would put on in the gown room. And the key is not to let anything hit the floor or any horizontal surfaces. You want to pay attention as you're putting these items on. And Steve will go through that when we enter the clean room. Once you're all gowned up, there's a mirror that's inside the clean room to your right as you walk in, and you'll want to look at the mirror and make sure that everything's properly secured. And anything entering the clean room, in this case we're not going to have hard hats, you may have safety glasses. You want to make sure any items you're bringing in are wiped down before you enter the clean room. And then after that, you put on your second set of latex gloves prior to entry. And when exiting the clean room, you're going to remove the Tyvek suit. Sometimes they reuse them if you hang them up. I think there's some gowning racks out there. And then usually you dispose of everything else. And this talks about, which you can read through on your own, talks about the different cleaning materials that we typically supply at each level, right? This is really related to construction shipments to the site. We typically make sure everything comes in shrink wrapped, and we bring it to the designated area for wiping it down before it's brought into the space. It talks about the same thing about making sure everything's protected and covered. Talks about the staging area, which is really construction related. But I guess the thing is, if you're going to be bringing any new materials, or if you're doing maintenance or things that to be repaired, after the warranty, you'd want to follow this as if it's construction, right? You really don't have a designated wipe down area. It's going to have to be that hallway before you enter the clean room.
You went through this part pretty fast.
Yeah, so this gives you an idea of what, it's mostly for construction related issues.
Okay.
4 stages of cleaning, continuous cleaning, clean room behavior, right? We don't allow any food or drinks or any of these items within the clean room. That's the most important part to get out of that. That's basically it.
How about the fans and stuff that feed these rooms?
Yeah, but the way this, I guess from an overall standpoint, the way this room is designed is I guess it's a central station air handler that provides preconditioned, pre-filtered pressurization air, right, to the space. And then we have fan filter units that recirculate air. I think I have a drawing that will show us that.
Basically, we're gonna really need is a detailed procedure for changing filters and when we can shut down, when we can't shut down, that kind of stuff.
Right. So this gives you an idea. This is a supply duct. If you, that's weird. How does that work? That's weird. I'm not sure why it's not recognizing this.
Try to move it to the right from your laptop screen, whatever you want to show.
So what, do you gotta drag it?
Yeah, just drag it. It's an
drag it.
extended screen. You're not mirroring your laptop screen, so this is just...
Is there any way we can get rid of the demo on the TV?
Yeah.
That's what I tried, but didn't push any buttons. Yeah.
Typically, when you replace filters, unless you've got a major breakdown of a filter that needs to be replaced immediately, do it during your shutdown times. Typically at Christmas, New Year's, when nothing's going on in the facility itself, you can go in and remove the filters. They're all room installed, so you just drop them out, replace the filters.
So they drop out inside the room?
Yeah. Just lower them down, put new ones back in, throw the old ones away.
So all contamination going into the room when it's
Right.
replacing.
You're gonna clean down. When you walk in that room with your new filters, you're gonna go into it's not a controlled area anymore. So you're gonna take the protocol that we showed you. They're bagged. So when you take the new filter in, it's bagged, split it open, raise it out, put the old filter in the bag, carry it out of the room.
Then everything's gotta be cleaned down again.
Just wipe down, yep.
How many times a year does the filter need to be changed?
Once every 10 years, typically.
Okay, that's reasonable.
Go back in another 9 years to have it set.
But you're gonna wanna certify the room every year, right?
Yep.
Okay. So this schematic here shows you the, basic design of the clean room. We have pre-conditioned air coming from the house system. We didn't put this system in. And then it enters the clean room, and then it splits off to two supply air valves that have been, controlled by Siemens, and they provide reheat to the space for a dehumidification, okay? And then basically it supplies air to the plenum that's above the clean room ceiling. Then where it says FFU, that's a fan filter unit. This basically recirculates air, so air is being brought down through the fan filter unit at 90 feet per minute, thereabouts. Then it goes down towards the floor, and then it comes up through the low returns and then recirculates on itself, okay? The Class 100 has 100% filter coverage, so if you look up at the ceiling, you don't see any ceiling tiles whatsoever. And then if you go into the Class 1000, you'll see it, say, 50% populated, okay? In addition to that, you have some process exhausts that go to the hoods. In my understanding right now, this is set up as a constant volume system. Your set points in the space, which are adjustable, controlled by Siemens at 70 degrees plus or minus 4, and then you have a range of 45 to 55% RH. And then pressurization from the Class 1000, we're looking to maintain 0.06, which is again all adjustable. Normally we go down to 0.03, and then to the next clean space, it's jumping up another 0.06 to 0.12. And you'll see a control panel outside. We have a separate monitoring system. Doesn't control, just monitors. Everything else you'd have to see through the operator workstation to see what the building automation system's doing. So we have the preconditioned air coming in, and then we have sensible cooling coils that are being fed 50-degree chilled water, right, to do sensible cooling. And these coils are mounted in the return air chases. So as the fan filter units are recirculating air, it's being drawn through the cooling coil. And then the cooling coils are controlled in banks, which we'll look at that. Off your house system, I believe you're providing 45-degree water. We're basically diverting it to maintain 53 degrees. And this is our chilled water pump, which will be the next subject that we're going right into right now.
So is there like a plate exchanger or something in a closed loop?
Nope.
No?
Nope. So basically they're all two-way control valves. So if we follow this through, you can see 45-degree water entering. You have isolation valves that are in the chase. So all this is inside the chase, which you'll see firsthand when we go out there. And then we have the diverting valve that will basically be controlled by Siemens to maintain 53-degree supply water temp, so we'll make sure we don't go below dew point. And this pump here runs, 24/7, 365, constant flow. Okay. And then we have a differential pressure because it's a two-way valve configuration, so we don't deadhead the pumps. But based on your lighting load and your fan filter unit load, it always should be providing cooling water to the coils. So if we were to follow this down, you will see control valves. So this control valve here is controlling multiple sensible cooling coils, right? Same with this valve here. It's kind of done in zones. And again, that's all being controlled by Siemens.
So there's no outside air whatsoever coming into these rooms?
There is, and that is going back to here. We need that to pressurize. That's coming from your house system.
Okay.
So if you ever work on your house, just be cautious. You need to keep this room pressurized. So it should be some, I assume this is multiple systems up there, right?
I would hope.
Yep. So we weren't involved in that scope, but you just don't want to just, if you shut down that system, you're going to impact the clean room. So just somebody has to be aware of that. And we'll actually go through and we'll show you the systems. You can see the majority of it within that service chase. This actually is, let's open up a plan. This is it right here. So if you go in this single door, this is a service chase. It's like L-shaped. And you look above the ceiling, you'll see where the chilled water pump's located. You'll see the mixing valve or the diverting valve. And you'll see some of the two-way control valves. The rest of them are somewhat local. I think there's one over in this area here that you can go through an access panel. And these here are your sensible cooling coils that you don't see there in the chase. There really shouldn't be anything unless there's a, something fails, which it shouldn't. There's really no maintenance on that.
A chase on an outside wall per chance?
Yes. There's a door from the common hallway into that chase area.
No, I'm just worried about freezing.
Oh, no.
No, this is all interior
it's
space.
Interior space.
Oh, it's all interior space,
Yeah.
okay.
So you have, this is sensible cooling coil 1, 2, right? Then you got 2 on the other side of the room, so this is the class 100 space. You can see all these are all HEPA filters, 100% coverage. This is the class 1000 space, so you got a sensible cooling coil here, located here, each of these chases, right? And then you can see why they're controlled in zones, right? So that's basically the sensible cooling system that we had put it under contract.
With these coils, obviously if you're keeping the water up at 54 or 55.
Yeah, that's key. We don't want
Condensation isn't really going to be an issue.
It won't be an issue if you're
Are there
above
drip
dew point.
pans if it is?
Well, the coils, I think they have
The
some
coils
drip
have drip
pans,
pans?
yeah. But it's not meant to dehumidify, so you want to
Right.
be very careful. If there's any problem with, if there's any condensation, you want to shut this pump down and investigate. Because it's uninsulated pipe. Because again, we're trying to minimize particulate matter into the clean room. And this thing's been in operation for the last couple days, and right, they're maintaining 53 degrees. So that's basically the 2 modules. And then if you look at, there's a I guess there's a test here that they wanted us to, that's in your packet, that they wanted you to fill in.
You don't graduate if you don't pass the test.
Everything's around the line, right?
Dad, I brought the Johnny material.
Oh, you can actually do that right now, right? Yeah.
Excuse me, sir. I got a question I meant to ask you.
Great.
On your chill pump in there, you don't have a backup, you just have one?
Yeah, we just have one.
Well, what happens if it fails or it leaks? What do we do then?
You gotta basically take it out of service and repair it.
Right, but I'm saying, and you...
I mean, we're not the engineer of record, so we put in, what was specified.
Okay, I'm just asking because
And you can put all kinds of backups,
it's never a 5-minute job, you know?
Yeah, understood.
Okay, I was just asking.
They're gonna lose sensible cooling, but you're still providing preconditioned air, right?
Okay.
Couple more questions. What are the conditions inside of the hoods? It is, I believe, 2 hoods in 100 space, and I don't remember what is in 1000. But what their conditions, temperature, pressure, humidity.
Oh, okay, we can sorry that. So in the class 1000 space, and again, it's adjustable, right? So we're showing here 70-degree temperature at
Plus or minus.
no less than 45% and no greater than 55% relative humidity, and the pressure relative to the ambient space, which is the corridor, at 0.06, And then the class 100 is basically the same temperature and humidity requirements, 70, 45 to 55, and then 0.12.
So pressure-wise, it's higher than in
Yeah, the
the
class
marine
100 is a higher pressure than the class 1000.
space? No, but in comparison to the room itself,
In comparison to
to
what,
the room, to the space in the room,
that's the pressure.
it is a
You're
higher.
talking about the fume hood in particular?
Yes,
or-
inside
Yeah, well,
of
the
it.
hood is going to be obviously negative, right? I mean, we didn't put
Right,
those
it's a
hoods in.
suction line
Yeah,
right
right,
there.
because you're trying to maintain a set velocity on a certain sash height, right?
Is it, how it is controlled?
It's constant volume, I understand. So it's
No,
always,
but inside of the hood, it is a separate fan?
yes,
but-
separate, yes, totally a separate fan.
And
we-
it's
we-
outside of the circulation, right? It's just an
I
exhaust.
assume it's going outside the building. We didn't do that scope, so
And is it internal control of that fan system?
it's not a
Or
variable
it's a
volume.
building
It's
control?
building control.
So whatever will be burst backward, for example, through the pipes will be going
No, it
directly
should
to...
always be under a negative.
Yes, should be, but
You know?
And with the room being pressurized, even if that fan were to fail,
Yeah, we're
it's
gonna
still
leak
gonna,
right
it's still
through
gonna
that
be
stack.
pushing air back out, yeah.
Yep. If you lose your exhaust in that room, it'll push the doors open.
Mm-hmm.
It's not gonna blow the walls out, it'll push the doors open.
Yeah, it's very
with the
small.
fan. Okay.
And one more question, how about the electrical ground line? What is the resistance for that ground line?
I don't think we did grounding, right?
Grounding is in, yeah, it's in the chase area.
It is actually in the question that clean room provides also the clean energy, which is include electrical and the ground conditions.
Yeah, there's grounding bars in the chase
Grounding
area.
bars?
Yeah.
Okay, we can get that data, right?
Yeah. Mhm.
I guess at this point, I don't know if you guys have finished your test, it's pretty straightforward. You could just probably leave them in the center of the table. Steve's gonna demonstrate, how to gown. And again, the university's gonna probably dictate what materials they're gonna use and their own procedures.
Okay, in fact, we've got two different rooms, one 1,000 and one 100. There is a difference in gowning up, the requirements for gowning up. And but like Ted said, the university will dictate exactly what those requirements will be, but we're going to tell you what Advanced Tech's requirements are. And in the class 1000, typical lab coat, okay? Hairnet, and for those of us that have facial hair, a beard cover. Hairnet. What I like to do is I like to put on a pair of gloves while you're gowning, okay? Gown up, peel those gloves off, get you another pair of gloves.